We can record for people who are not coming. I think no problem. Okay, in the last two chapters, if you remember, we talk about physical and we talk also about chemical. Today we start topic number 3, biological. In your syllabus, you have many chapters, but I try to combine all in, I divide in physical, chemical, biological, and it will be easy for you to follow. If we follow syllabus one by one, it will be difficult because there are different topics and it is mixed with each other. So I try to make it more clearer. In the biological, you see here, when we make, last time we talked about preliminary and primary. We talk about, this is physical because we are talking about filtration. We are talking about screening. We are talking about this kind of things. And then we talk about chemical. We saw that about coagulation will be chemicals. Today we'll talk about biological. And here, if you see this area, we make aeration. What we mean by aeration? We introduce oxygen through air pumping so that it goes, and then mixing. So bacteria utilize oxygen and also break down hydrocarbons, whatever, either nitrogenous compound or hydrogenous compounds, and then became clear water, and then go for final stage. Okay. Here in this one, there is one example for activated sludge. Activated sludge is mean that we treat waste biologically by using bacteria. And this is, we call it activated sludge. Activated sludge mean that sludge active or rich with bacteria, and this bacteria could be aerobic and it could be anaerobic. What is the difference between aerobic and anaerobic? Aerobic needs oxygen to utilize. Anaerobic will use oxygen in the compounds themselves, mean that degrade compounds and utilize oxygen from there. So no need for oxygen from air. Okay. So here, if you have from home, industry, whatever waste coming, and you inject air here, aeration, and bacteria here will work and divide or degrade hydrogenous or carbonous or nitrogenous compounds and form here sludge. Okay. And then go for overflow to clarifier. In the clarifier also there will be clean water and also sludge. So sludge will be precipitate here. We can take from here. We don't have to take all sludge because this is very rich with bacteria. So we need to return back some of this bacteria to be all the time in the aerobic digester. Okay, and we take part. If we return all sludge here, this will be full, so difficult to treat. So we maintain certain level of sludge, which is rich with bacteria, to work as activated sludge process. And here, hydrogenous, carbonous, phosphorus compounds will be degraded here, and clear water will go out. So this is one way. Another way is aerated lagoons. This is very big, huge, as you see, like pond, and we call it suspended growth process. This is also need aeration. So aeration lagoon system consists of large pond or tank that is equipped with mechanical aerators to maintain aerobic environment and to prevent setting of the suspended biomass. This needs usually, this ponds, if you go to palm oil field or industrial field, usually takes very long time. This is why biodegradation is very good, very cheap. However, the time needed is very long. This is one of the disadvantages of biodegradation. Another thing is anaerobic treatment, converts organic matter in wastewater. This is bacteria will not be aerobic, will be anaerobic. So usually cover area We will talk later about in palm waste, palm oil waste. We will talk in second details. So this anaerobic treatment will be utilized oxygen in the waste itself, because you have hydrocarbons containing also oxygen, or other contaminants containing oxygen. So bacteria utilize oxygen in the contaminants itself and degrade the contaminants and produce clean water. This we call it anaerobic treatment. And this anaerobic treatment is very, very, very important, especially in Malaysia, because now they are trying to take gas, or biogas, we call it, which is fuel, mainly CH4, to be used as in houses or wherever. So this usually through an aerobic process. This palm treatment in Malaysia, what is palm? It is palm oil mill effluent. Palm oil mills effluent. This in Malaysia policy to produce biogas. How they produce biogas, we'll see how. For example, you have this big field. This is palm or waste from palm oil industry. So they cover this with a very thin layer of plastic that can be like, see, when gas became full, when anaerobic bacteria work and gas produce, they don't let gas go out. They trap this gas through trappers and then get gas. Okay, and this can be utilized at homes or whatever as energy, maybe for cars, for whatever. In Malaysia, it looks like this one. This is actually palm waste coming from the field, and this is here. And here some areas they already start to cover with this kind of trappers. What is the mechanism reaction? You see here. Here you have the waste, organic materials, carbohydrates, proteins, fats, oils, all this will be here. And then through anaerobic, this will be sugar, amino, fatty acids, and then go anaerobic digestion. You will get here two products, H2CO2 and also CH4CO2 H2S. Okay, this will be utilized as biogas, but better to remove H2S because H2S is as make corrosion, so it is not recommended to have in our fuel gas H2S. So we need another process to remove H2S, and this is one project last time is FRJS by Mr. Hadi, FTKK last time. He got a project to remove H2S from palm oil waste and from other gases to be used as fuel, and then go as digestion effluent, residual solids and waste. So you see, from waste we also can get some energy. Okay. This is another thing about biodegradation. Nutrients cause etrification. Last time we talked about etrification, but in second details, not in details. Today we'll try to talk in a little bit details. What is etrification? Etrification means that the waste coming from homes, from industry, from anywhere, which is rich with carbon, nitrogen, phosphorus, it goes to the sea or to the river. And once it goes to the sea or to the river, bacteria became very, very aggressive. Once became aggressive, it means that too much food. There is too much food, so they utilize too much food. Once they utilize food, they use too much oxygen also. So all oxygen in the water column here will be consumed by bacteria. Once this oxygen consumed by bacteria, meaning that there is no any oxygen left for fishes and other species in the sea. This is why this will be die, and plankton also will die. And you see here in the top red color. This we call it red tides, and mainly plankton die and other fish. If fish die, will not be in the top, will go by the waves to the seashore side. This also very bad for the bivalves. For example, in Malaysia, you say in Malay is kerang. This also die. Crab also die. All those because of eutrophication. Eutrophication means too much food for bacteria so that it can utilize all oxygen in the water column in the sea or in the river also. Hopefully you understand. This is how it looks like. Another thing about it looks like eutrophication, but suspended solid or turbidity. You see here, when turbidity is too much, heat absorb all, cannot go release another time. So it water column here will be very hot. Once also water column here very hot, meaning that bacteria also very active and consume all oxygen. So this also cause dissolve oxygen level to drop below the normal. Okay. So here you see here too much suspended solid, meaning that all sunlight rays will be absorbed. This will become hotter. Here, this is the normal case, meaning that about 40% will go out again. Okay. Another thing is suspended solid turbidity prevents sunlight to reach sea bottom. For example, from here, also turbidity cannot go all sunlight to the bottom, and that is very bad for the algae or chlorophyll A. Algae, when there is not too much sunlight, photosynthesis process will not occur, so start to degrade. Once degrade, it will be also food for the bacteria, meaning that also all oxygen will be utilized because of degradation of this algae, or you say in Bahasa alga. Okay. Another thing is this alga or algae is very source for oxygen, to produce oxygen. When there is oxygen coming and utilize some contaminants or some food here in the sea bottom, it produce also oxygen. So it important of this algae is to enhance the production of oxygen. However, if too much suspended solid, no sunlight is coming, means that this also will be damaged. Another thing is about suspended solid turbidity affects also fish activity. You see here, this is turbidity, here different NTU, okay? Here start at the beginning for the first time, start to show sign of stress, fish, okay? Here, what increased respiration means breathing will be much more fast. And also feeding rates will not be able to eat too much normal fish. And then here, if you too much time, longer time, and too much turbidity also, it gives also delay hatching rates. It means that no new generation, okay? And also reduce growth of the fish. And finally, if you see here, will be the death. So these fishes also cannot survive in eutrophication or too much suspended solids. So you see, if we are using our waste from factories, from homes, just we throw to the sea or to the river, you see how much the effect on us. Even if fish survive, but too much heavy metals or some hydrocarbons or some toxical material, this also will come as a food for us and affect our health also. So this is why in Malaysia now there are, and before also there are some rules. Factories must release, there is you know, it's called standards. They have to follow the standards. For example, suspended solid not more than 100 part per million. You cannot send more than this. Sorry. Now classroom. Yeah. I will come now. Okay. No. Very sorry. Emergency call. Okay. So you see the effect on our aqua or we call it marine life or river life if we don't follow the SOP or procedure. There is one important factor in biological. We have something called nitrification, and we have something called denitrification. As you see, nitrification here, NH4. So meaning that needs oxidation, need oxygen to degrade. So here, aerobic bacteria will be used, not anaerobic. And then finally, we'll get NO3, and then finally, here, denitrification, you will get N2. So in order to get complete process inside the sea or inside the river or inside the soil also, you have to get nitrification and denitrification bacteria, so any contaminants can be degraded. Finally, will be N2, this is will release as gases. Okay. Here also nitrification, denitrification, how to differentiate between both. Nitrification here needs oxygen. Okay. Here COD needs oxygen in the component itself. This nitrification, this is denitrification. Here there is some more equation about nitrification, denitrification. You can study later. How to calculate BOD? Some of you do their final year project and they don't know how to calculate BOD or biological oxygen demand. That is very easy way and we need to measure for at least 5 continuous days. I will talk in little bit details about this and how to make the graphs. BOD, usually milligram per liter or parts per million, will be D1 minus D2 minus B1 minus B2 F divided by P. What is D1, D2, B1, B2, F, P? D1 is dissolved oxygen of diluted sample immediately after preparation. D2 is dissolved oxygen of diluted sample after 5 days incubation. B1 is dissolved oxygen of seed control before incubation. Incubation, usually we have incubator and it is 20 degrees C. We have to put our sample inside the incubator for at least 5 days. And B2 is dissolved oxygen of seed control after incubation. F is fraction of seeded dilution water volume in sample to volume of seeded dilution water in seed control. Okay. P is fraction of wastewater sample volume to total combined volume. We have one example here. I think in lecture notes number 1 I give to you, this also there. The following information is available for a seeded 5-day biological oxygen demand test. Here what you have here, 15 milli of the waste sample added directly into 300 milli bottle, incubation bottle. Okay? The initial dissolved oxygen of the diluted sample was 8.8 milligram per liter, and after final, it means that after 5 days became 1.9. So you see here, the beginning was 8.8 and here 1.9, meaning that there is bacteria, there is some activities. It consumes the oxygen, okay? And the corresponding initial and final dissolved oxygen of the seeded dilution water is 9.1 and 7.9, 9.1 and 7.9 respectively. What is the 5-day biological oxygen demand of the wastewater sample? 5 days we make BOD and we put subscript 5. It means that for 5 days, okay? You see here how to determine the 5-day biological oxygen demand. We use the same equation I explained before. F will be how much? Will be 300 minus 15. This is the sample volume divided by total. This is volume of the sample volume. How much sample volume? Will be 85 or 285 divided by total volume of the sample will be 300. You will get 0.95. What is P? Will be 15 divided by 300. Oh, this is P. P is volume of the sample divided by total. But F is 300 minus 15 So 300, this is volume of, if you see here, maybe I can go back previous. This 15 is what here? 15 milli of the waste sample. Okay, so waste sample is 15. Divided by total, you will get 0.95, and then you calculate BOD5 will be 8.8 D1 minus D2 minus B1 minus B2 multiplied by F divided by P. You will get 115.2 milligram per liter. This is very easy and straightforward example, but we have sometimes to draw. I will show you more examples to see. Question 2 say calculate the 5-day BOD of domestic wastewater based on the following data. Volume of wastewater added to 300 milli bottle 6 milli. So you have 6 milli. If you want to calculate P, this 6 milli divided by total 300. Okay. And D1 initial 8.1 after 5 days became 4.2. What is the ultimate BOD assuming a K rate of 0.1 per day? So here P will be 0.02, BOD will be 195. Ultimate will be BOD divided by 1 minus 10 to the power minus KT. This K is given to you here, time 5 days. So you will get 285.18. And also same unit, milligram per liter. We go to question 3. Question 3 more because there is drawing. What it says, determine the 5-day BOD and K rate of the raw domestic wastewater based on the following data. So you have here time 1 to 1.1, 2.2, 4.3, 6.3, 14.4. You see here 5 data, 5 days. So here we need to make interpolation if we don't have to draw. We can draw. I will show you how to draw and how to take this value from drawing. Okay. D1 given to you, C 6.7, 6 here, and then 4.7, and then 3.8, and then here 2.4. But initial was here 8.3 milligram per liter. So D1 will not be changed because this is the initial at 0 time, or at the beginning, or the first time you start to do your experiment, you will measure dissolved oxygen. So this will be constant, not change. All right. So what is BOD? You go, we calculate for one, we calculate for the first one, and then similar you do for the same. Total volume is 300. Okay. And here P will be 6 milli because we have 2% says 2% of wastewater mixed. So it will be 6 milli, meaning that P will be 6 divided by 300, 0.6. Total 300 the volume plus 6. This is the waste volume will be 306, will be 0.02. So to calculate BOD1, this is for the first day. BOD1 here. For the first day, we go D1 minus D2, D1 minus D2 divided by P. This is your P. So you will get 80 milligram per liter. You do for 2.2 the same also. You do 8.3 minus 6, not 6.7. Divided by 0.02. You will get 115, and then you go so on and so forth. Finally, you will get up to 14 days altogether. Okay. Then you need to add one more column. It is called T divided by BOD all to the power 1/3. Don't confuse and don't do mistake. Take only BOD to the power 3 or T to the power 1/3. Take all and make 1/3. Hope you understand. This is very important because most of you do mistakes with these problems, with this kind of small mistake, but it makes big significant effect on the results. Be careful, huh? So here to calculate T over BOD to the power 1/3, time is 1.1, so will be 1.1 divided by BOD is 80, and then take all together to the power 3, you will get 0.24. Why we are doing this column, I will show you later why it is very, very important, because from here you can find the reaction rate. You can find the reaction rate, okay? So you do for the second one, for the third one, for the fourth, for the fifth, you will get all those values. All right. Now to find out 5 days BOD, I will draw time with BOD, like here. This is here, very sorry, not very clear, but this x-axis will be BOD, and here will be time. So if you draw, you will put your point, and then just you connect. Okay? And here at 5, exactly 5 days, because you don't have in the table, at 5 days, you go and make straight line, and then you go opposite side. So you will get your exact value of BOD5. Is it clear? Clear, Ta?
Yes, sir.
Clear, okay. Okay, Alhamdulillah. We go to next drawing, because I told you how to T over BOD all to the power 1, 3. What is why very important? We see in the next slide. Here. You go to draw here also, here your time, x-axis. Here will be T over BOD all to the power 1 over 3. So you put here your time. Here you go T over BOD all to the power 3rd. Okay, and you put your point. Okay. And from this you take the best points, you make straight line. You make the best point to make straight line, and you connect this line. Clear? In BOD5, no need to make straight line, just you make normal, you connect the points only, not straight line, huh? And you go to 5 to take. But in the second one here, you need to make straight line. So you take the best point. I think I showed you last time in water pollution or pollution control. I show you how to make, but not in details. So here maybe you can, if you cannot understand now, you can go back to this slide and watch again. Huh? So here you make slope of this line. You make slope of this line. For me, I take these 2 points and I make the slope. Slope will be delta y divided by delta x. All of you know, of course, right? So you take, this is y1, this is y2. So if you take this y1, this will be x1. This will be x2. Okay? Don't confuse. Take this x1, y1. You take this x2, tabule. It's wrong. You take this y2, you take this x1. No. This is y1, x1. This is y2, x2. Or opposite, also same. This is y1, x1. This is y2, x2. Okay? And you will get your slope. Another thing is this intercept. We call it intercept here. From here to here, how much? From 0 to here, how much? This point also very important. So if you look here in the graph, not very clear, but you will get 0.25. You will get 0.2. So A is intercept here. This from here to here, from this point to here, this will be A. Okay? Maybe I can, this need to, this from here to here, this will be A. Okay, clear. فهمت فهم.
Okay, sir.
Okay. All right. So this is A, and B will be your slope. And from here, from this equation, you can find out that K will equal 0.086 per day. So from 2 graphs, you can calculate from the first graph is BOD5, 5 days biological oxygen demand. From the second graph, you find out K, rate of reaction. This one K, huh? Okay, we go to question 4. Oh, this. We go to question 4. Here you have data here, time also given. You see here also 5 data, so 5.3. Okay, you have dissolved oxygen 1. You have the data from here. I summarize from here. You can read. I don't have time to waste and read this all. So I summarize all data here in the table. Okay, so time here, dissolve oxygen 1 will be constant. We say that will not be changed. This is the 0 time or starting experimental time. This D2 will be changed based on the day. For example, 7.2, or we start 1.3 day, 1.3, 7.2. This is 7.2. 3.3 days became 6.4, so on and so forth. So you put your data here, and then you go to calculate BOD. How to calculate BOD? Dulu, the beginning, you calculate P. P, we have the volume of the sample is 60 divided by 300. This is total volume of the sample. You will get 0.2. To calculate BOD1 here will be 0, right? Because here 0 or 8 minus 8.1 minus 8.1 will be 0. So you will get all 0. Second one also, you go for the, you calculate D1 minus D2 will be 8.1 minus 7.2, okay, divided by P, 0.2, you will get this value, 4.5. And then so on, so forth, till you will get the final value. To calculate T over BOD all to the power 1 over 3, you take time here, BOD here, and you calculate, and don't forget this, very important. If you don't do this one, will give you wrong results. Be careful again and again, huh? And then I draw time with BOD 5, and then I draw time with T over BOD all to the power 1 over 3. What I will get, you see here. Sorry, this is by hand, but I will show you one example. You can use also Excel. Tada masala, bole. No problem. You can use also. But in the final, usually, if you come here, we don't allow you to use PC. So you need to use by hand. You need to draw by hand. You need to know how to make that by hand. So here you go. This is time here. Here you have BOD. So here you have 5 days. You go here and you go to the opposite side. You will get your value exactly here. BOD 5 will be 10.8. If you draw and you don't get the same answer, maybe I am wrong or you're wrong. You check or we discuss together. Huh? Second thing is, this is your time here. This is T over BOD all to the power 1 over 3. I will make also my points here, and I will make slope. I will calculate. Slope usually delta y over delta x. I will take 2 points in the line. Don't take out of the line. If you take out of the line, you will get wrong. For example, you see point here, here. I will not take this point. I will take the best point represent the line. I will take this line with the maximum point inside. And then slope, I will calculate from the line, from the straight line itself. I will not go here. This will give me wrong results. Try to understand. Bole. So I will take this point. I will take this point. That is will be here y2, y1. This will be x2. This will be x1. I will get 0.016. Okay. What about intercept? I will go again here. This from here to here. This will be my A. So I will take this point here. Okay. Maybe I can make it big also to make you understand. This point, huh? Okay, and from here to here will be my A. Okay? Okay or not okay?
Okay, sir.
سكت بوله, you should not sleep.
No, sir. I'm not
Don't
sleep.
sleep. Okay, it's okay, okay. And then K, I calculate rate of reaction based on this slope and intercept. I will get 0.02 a day. Okay. We go to question 5. There are many questions, but I will not try to solve all because I have other topic to talk. But also here the same. Here exactly also the same. You have here quantity of the sample 4.5. Here total volume. So you can calculate P. This is P capital, not small. And then I will get 0.015. D1 here given the initial 8.1. Dissolved oxygen 2 given for each day 0.6, 0.9, 1.7 till 5. This 5 will be exactly here. Okay, tada masala. This will be BOD 5 will be 4 to 6.67 because here origin. So if you draw or you don't draw, you can get from here. Not a big issue. Okay. But this one to calculate here the amount of the rate of reaction, because here also calculate rate of the reaction. Mana? K rate, this one. Okay, so it's given. So if I calculate, I will get this value. This one 0. This one 0 because here 8 minus 1 minus 8 minus 1 will be 0, and then I calculate the others, and then I go to draw. This is the first C. This is by Excel. So here 0 time, and then you go. So BOD5 will be here. You go here. This will be BOD5. So will be the same as previous, as you see here. Same, right? 4 to 6.67. Okay. But for rate, K rate, how to calculate? I will do also the same. I will take time. I will take T, BOD, all to the power third, and then I will draw the point, and then I will make straight line. If you make this little bit longer, we'll come to 0.13, around 0.13 here, 0.13. So slope, I calculate from 2 points of this line. I will not go for this. I will go this line, straight line. I will get slope 0.0123, and then K equal 2 points. This is constant. This is in the equation. This will be. This is given. There is equation say that K equal 2.61 multiplied by slope divided by nobody divided by, this is slope, this is intercept A. Okay. This question 6 also the same, but here I have seed. I have seed test B2. I have also D2. So if you read, this is the time here given to you. Okay. And given to you time from 0 to 19. This one table, but because long, I made it in two parts. Huh? So this is time 0, 1, 6, and then go here 7.9, and then till 19. And seed test milligram per liter 8.2 till 3.8. And then here sample test D2. This is for dissolved oxygen from 8.2. This is the beginning. End is 2.1. So I need to calculate also K rate. Calculate the K rate. Huh? First of all, I calculate P. P is 1 over 300. I will get 0.0033. Okay. And F will be 0.1. How to calculate this? We already show in the previous slide. The first problem. In the equation that we use that equation. Here time, I make it in one table, all in one table. B1, this is the beginning. This is B2 after different times. So I will make B1 minus B2. I will get another column here. D1 minus D2. This is initial. This is after every day, or not every day, every time here specified. And then here I minus 8.8 will be 8.2 minus 8.2 will be 0. And then I go here minus 7.2, I will get 1. And then so on and so forth, I will get till 6.1. How to calculate BOD? Also the same criteria. Okay. I will calculate BOD, or I will use D1 minus D2 divided by P. Equation, you want to see the equation a little bit long, huh? Because there is F also. You see the equation before. Equation at the beginning before exercise 1. And then I calculate T over BOD power 1 over 3. I will get all those values and I will go to draw. So BOD 5 will be, I will go here, this is 5. I will go here exactly, and then I will go. So it will be 892.64. This in Excel will be very clear because you can get the values. No mistake. It's not like predict. Will be exactly value, huh? If I want to calculate rate, K rate, I will make also straight line here based on the data. You can select in Excel that to make straight line. It can make for you straight line. But you must intercept the y-axis so that you understand how much. Here it is just if you make straight line will be not 0.15, will be less than 0.15. This will be 0.145. So this is the slope. Slope, I will take 2 points. Okay. Usually here, if you got the equation in Excel, this y equal 0.0058x, this will be the slope. And this will be the intercept. Because y equal ax plus b. How it comes, maybe better to write for you. Y equal a plus b x. This will be your intercept. This will be your slope. This is for straight line equation. You study in mathematics or no? Study or no?
Yes, sir.
You study. You remember Siket or no? Remember La. Okay.
As last year.
Anyway, I already explained. So if you study this one, will be enough for you to understand. Okay. Here also another equation, seeded BOD, also answer also here. I think no need to waste. You just look and see if you have any problem. I will send you this file. Huh? I will send you this file so that you can study. Huh? No problem, inshallah. Okay. We go to another topic. It's not very long, but very, very important. For example, during Banjir, during flooding time in Malaysia, if you notice that kids especially, they got diarrhea. It means that they have to go to the hospital. They have problems, stomach ache. They have many problems, especially kids, and also old people. Also us. What is the reason? During flood area, actually, there is biological, some microorganisms coming with drinking water, so make this kind of problems. So in based on standards and regulation, drink you supposed to drink doesn't contain any bacteria, supposed to be 0. If there is any positive test for bacteria or viruses, we suppose not to drink. You know this or no? You don't know, but you know now. You don't. So how we make this test? if there is bacteria or no bacteria in the waste or in drinking water. There is something called multiple tube fermentation technique. This is very important. Or it's called multiple tube fermentation technique. What we mean by multiple tube fermentation technique? This is the meaning. We are talking about bacteria and viruses, chloroforms, including bacteria from feces, soil, and other origins. It is the most reliable technique for emulating total chloroform and thermotolerant fecal coliform in wastewater surfaces water. Attached figure show the laboratory procedure. So what we are doing, we take the waste water here, and we put in something called fermentation tube. Okay, so we take from here, and we put in the sample. Or this is the original. This is the original, and then we take in the fermentation tube, and we put incubation at 35 degree. Why 35 degree? Because bacteria very active during 35 degree, and between 25 to 35 very active. Okay, okay. So here we check the test tube after time. If there is space here, there is a bubble, then we understand this sample contain bacteria. Why bacteria? Because there is consumption of oxygen. There is oxygen, or there is gas released. Maybe this gas, carbon dioxide or whatever, but there is microorganism activities in the sample. We understand. Okay. So how to know the total number of bacteria is difficult or easy? It's actually very difficult to go one by one. It's tabule, because we cannot count 1, 2, 3 like that, because sometimes you have million, and growth of bacteria sometimes very fast. So what we are doing something like this. We go dilution and dilution, dilution. We take one sample, okay? We take water sample, and we put 1 milli from the waste, and we take 99 or sterilized water. It means that clean water. This is, we make sure that there is no bacteria here. Okay. Okay. So we take 1 milli plus 99. This will be 100, right? And from here we take again 1 milli and we add 99. And from here also we take 1 milli, we add 99. Okay. But down we go down, we take from this 1 milli and we add 99. We take here 0.1 milli, we add 99.99. So you see we have a series of tubes. We have too much tubes. And then we go every day to check there is bacteria, there is bubbles or no. So here, like, it looks like this one. If you see this one, there is no bacteria, right? Bitol. If we take to this one, there is space here, meaning that this is positive. This gives positive results, meaning that there is microorganism. So how to check the total number? Because we have dilution, series of dilution. We go to table. We have table here, maybe like this one. So we go here for 5 samples. For example, 5 samples. If I have all 0, meaning that MPN is 0. What is MPN? Maybe I need to explain to you what is MPN previous. Okay, this MPN is called most probable number. So most probable number means that we use probability, we use statistics. I think you study statistics. So based on dilution factors, we can predict how many number of bacteria. This is bacterial density in water sample can be determined by serial dilution in multiple tube using the fermentation technique. The results is reported as the MPN based on tabulated probability tables and expressed as MPN divided by 100 milliliter. Attached figure show the test preparation. And this is the figure, huh? Okay, we see how to use this to make it clear for you. Bole, we see how to use this table. For example, I take a sample from any wastewater, okay, and I make serial dilution. I make 0 at the beginning, 1, 2, 3, 4, and then I add sample portion to each one. I add here 1, here 0.1, here, see this one, 1, the original. I take 1 in 10 milli, for example, or 1 in 9 milli dilution, so it will be 0.1. If I here take from this sample 1 and I add 9 milli of distilled water, will be 0.01 from the original here. This will be from here I take and make dilution, will be 0.001 from the original here. Here I make dilution, it will be 0.001 from the original here. From this will be 10 times dilution. From the original will be 10,000 times. You understand dilution? Dilution, I think you know, because in chemia, sometimes we need to make dilution, especially when we are measuring like standard, like if detection limit, if sample concentration is high, then we need to make dilution. So dilution will be, if I take 1 milli and add 9 milli, in this case will be 10 times dilution. If I add 1 milli into 99 milli, this will be 100 times dilution. I think you understand this. If you don't understand, we can explain one more time, no problem, next time. So here, in this sample, how many I have for each one? 5 tubes. So here, it gives me 5 out of 5, all positive. It means that there is space. There is like this one, like this. There is bubble, there is gas. Okay. In the second one, it gives me 4 out of 5. Okay. In the third, it's giving me only 2 of 5 because this is a small amount, right? Dilution other. So this will be because here high concentration. And in the fourth, give me 1 positive out of 5. And in the final, because too much diluted, it give me 0 of 5. So in this case, how much the number of bacteria or MPN I can expect in the sample? Oh, this is very, you cannot go one by one to count. So we use the table. Here, if I have something like this, 4, 5, 4, 2, 1, what I will take? I will take 3 successive reading. Kalau ada 3, for example, 5, 4, 3. I will take 5, 4, 3. But here I have 5, 4, 2. I have also 1, 2, 4. I need only to take 3. I cannot take more than 3 because the table only I have 3 values. So here, if I take 1, 2, 4, this is too much diluted. Okay, so you see 1, 2. If this is 3, I will take this one. But this is 4. If I take from here 1, 2, 4, this is too much diluted. If I take from here also 5, 4, 3 tada, 2, 5, 4, 2. Here 1, 2, 4. So I will take from this because here more probability to be contaminated, meaning that number of bacteria, because this is high concentration. So I will take 5, 4, 2. If 5, 4, 3 will be more accurate results. If 1, 2, 3, I will take 1, 2, 3. But here 1, 2, 4, I cannot take. So I take 4, 5, 4, 2. 5, 4, 2 here. How I understand MPN? I will go to the next table. Okay, I will go here, number of test tube given positive reaction out of 5. Okay, here 5 of 10, 5 of 1, 5 of 0.1. Why here dilution 10 times? Huh? Dilution 10 times. So you see here 5, 4, 2. How much MPN? It is 2, 2, 0. 2, 2, 0. Okay. What about low and high? This is probability with 95% confidence. This, I think, in probability, you know, if I want to increase the confidence, I have to be more accurate. But this is 95, it is more than enough. So meaning that it is really very accurate. So here, if I go back, this MPN will be 220 multiplied by 10 because this is dilution 10 because I take from top. Okay, so will be 2200. This is MPN. Confidence limit will be 70 low multiplied by 10 will be 700, and high will be 440 multiplied by 10 will be 4400. So my range will be, this is the most probable number here, and not less than 700. If I say that I have 750 number, it is wrong. It is right. Okay, less than 700. Okay, and here also not more than 4,400. If I said 5,000, it is wrong. I don't have 5,000. It is between 700 and 4,400, and it is approximate 2,200 MPN. Understand? So we cannot, meaning that we cannot go for each bottle or each test tube, fermentation tube, and go to count 1, 2, 3 under microscope or whatever. It's very difficult because it's bacteria. Sometimes growth in million, you know, it's not that easy. But we use this table, probability table, and you can find out exact number. Okay? Understand, Siket, or no?
Boleh, sir.
Boleh, okay. We go to another example. If boleh, then we go to another example. Here I have two types of bacteria, EC, E. coli, and then we have Laurel. This is also another type of bacteria. Here dilution I have 1.1.0. Okay. Allahu Akbar.
Emergency call.
I have class. Wait. I will come. Wait.
Take your time, sir.
Yeah. After class. Wait. After class. Okay. Very sorry. Too much urgent calls today because. So here, which one you will select? Here I have 55200. Which one you will select? Here also I have 0025. Which one you will select? You will select 552 or 520. Here, you will select 522 or 022. You need to know. Okay, we see here. Here I selected the first one, 520. So if 520 mana 520 here, right? This is 520, right? Right or wrong? So I have here 49, 15, 150. But I need to multiply by dilution factor. Okay. So here 49 multiplied by 100, I will get not 10 here 100 because I take from 5. Here also I need to multiply this 5. I will take 522. This one. Okay. Here I will multiply by 10. So here 34, 230, multiplied by 10. I will get here 940, and this is the range. And this is here the range. You understand how to use the table? Boleh
sikit.
If kalau tak faham, inshallah next time. But I want you now to study. This is the last your syllabus. We have one more chapter about analytical instrumentation. This will be your mini project. So you work in groups or individual, to because maybe next week or next week we have our presentation together, inshallah. Huh? We make it live presentation so that we get benefit, all of us. Boleh? Because some of you ask me, what is the topic of mini project? I think in the first lecture I already told you what to do. You select one analytical instrument and to make intro and theory and where it can be applied and all that related to that instrument, particular instrument, or to be more specific, analytical instrument. What analytical instrument? Like UV, like IR, like atomic absorption, like there are many, like XRD, XRF, like SEM, like TEM also. So there are different analytical instrumentation. You can select anyone you like, you feel that you know more better, and you, with your friends or alone, we make presentation. Any questions so far?
No, sir.
If no, then I think I can stop here, and it is already recorded. You can study one more. Difficulties or difficult questions or difficult slides you don't understand, you can ask me, and we can discuss together one more time. Huh?
All right, sir.
All right, but your lecture, you're already habis. Oh. Your syllabus already finished, huh? Okay. I will make one more time attendance because some of you maybe came late or already taken. Allahu Akbar. Okay. Who will not attend? I can just see only one. Fatiha today. What happened to Fatiha?
Don't know, sir.
Don't know. Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
Alah.
Dah kabur.
Oh, ada.
Akang
Kau ini.
lu. Allahu Akbar.
Aku seorang nak jawab kan.
Deng, keluar deng. Keluar deng. Deng.